Welcome to this introduction to MATLAB. My name is Kenneth Eriksson and I like MATLAB a lot. So this is my favorite tool, both in work and for pleasure actually. And the purpose of this small mini lecture is to give you a very first introduction to MATLAB. So here I've started the program. I hope you will be able to find this on your computer and get it started so we can take a first look at the MATLAB environment. So this is how MATLAB looks nowadays. When I grew up with MATLAB many years ago, what we had was only this central area, which is called the command window. So what you see here is the so-called MATLAB prompt sign. So here is the place where you can issue commands to MATLAB. Such a command could be something very simple, just using MATLAB as a calculator, 3 plus 4. You print this on your keyboard and then you press the enter button or return button and you would get an answer, which is 7. So this is a place to issue command to MATLAB to get things done. What you see to the right here, it is what is called the workspace. This computational result that we got in our first calculation, the number 7, was put in what you could imagine as a box called the answer box. This one is always created for you unless you say that you want your computational results placed somewhere else. But the answer box is always around. But that means that you also have to be somewhat careful about it because you can easily overwrite the content in the answer box. So if I now do a new computation here, 5 plus 6, there will be the number 11 as a result. And now this 11 is placed in the answer box. You can actually see the answer box up here to the right, and you can see its current content. When the content is only one number like 11, you can actually see it displayed here. Below this window, you have the command history. This is simply what it sounds like. It's a history of all the commands you have used so far. To the left of the command window, you have some parts of your file system, if you would like to access that. And below here is some details about that. You can look at individual files and so on. And then you have the top menu here with lots of things. I'm not perfectly an expert on all this because I grew up with the command window, so I can do most things by simply releasing commands like the one I did here. So the basic data type in MATLAB is numbers like the one we have seen here, like 2.3. As you see here, MATLAB can display numbers in different ways. If MATLAB thinks that you are dealing with an integer, it would be displayed without any decimals. In this case, I wrote 2.3, and that will introduce you to one particular aspect of MATLAB, namely that you use decimal point rather than a decimal comma. So MATLAB uses a decimal point rather than a decimal comma. You also see that MATLAB can display numbers in other ways. This format that you see here is called long engineering format. So you will see the decimal part of the number, and then you will see E means exponent 10. So this means 10 to the power 0. If you have big numbers, you would have other exponents of 10. So we can write, for example, 2.3, or we can write, 2.3 or 0.23. The normal format, if you go back to that, is what is called short in MATLAB. So normally you see numbers like this, but then I have to change format to what is the default. This is called short. So normally when you write 2.3, you see the number like this. This means that you are displayed only 4 decimals, although MATLAB carries lots of decimals all the time, but you get to see only as many as you like for the moment. And the default is 4 decimals. There are, besides numbers that you create yourself, some predefined numbers, some predefined constants in MATLAB. For example, you have pi, which is 3.14 something, and you see part of that number here. If you like to see more decimals, you change format to what is called format long or something else. Then you get to see all the typically like 16 decimals that are around. Of course, you can do arithmetic with numbers. You can add, subtract, and multiply and divide. So when you multiply, you always have to write out the multiplication sign, which is a star in MATLAB. So 3 times 4, of course, is 12, as you see here. And when you divide 3 by 4, you do it like this, and you get 0.75. 0.75. Again, I remind you that you use decimal point rather than a decimal comma. If you write 2,3 like this means that you have just 2 numbers, and comma is just a separator. So this means 2 and then 3. And these numbers in turn are then placed in the answer box. No big deal about this. Once you get tired of doing multiplication like this, you change and use what is called the power. So then you would write 3 to the power 4, like that. This means 4 factors of the number 3. So power is written with this roof-like symbol like that. So this makes 81. Besides these products, so again, multiplication sign must always be written. So you cannot do, for example, things like this in MATLAB. This does not make sense. 3 plus 4 makes sense. That makes 7. But 2 multiplied by 7 here doesn't work. So you get an error message. Something is missing here. And what is missing is the multiplication sign. So multiplication sign must always be there. And the same with dividing, of course. Now it makes sense. 3 plus 4 is 7. 2 times 7 is 14. What I was about to say, that beside the multiplication symbol, you would later see that we need a friend of this, as this is dot star. Dot star, and also dot divide, and also dot power are variants of multiplication and divide. And you use this when you multiply many numbers in vectors. We should come back to this in a moment. When you have to deal with only single numbers, there is actually no difference between these. So if you would like to do 3 by 4, you can write it like this, and you get 12. But of course, there is no point to use the dot here, so you can write it as well as this. If I go things a little bit ahead, the star as it is, with just the star, is reserved in MATLAB for matrix multiplications. And you know that matrix multiplications is more complicated than doing multiplications with single numbers. So we shall come back to this in a minute. In MATLAB, you use the normal priority rules. So that means that if we go back to this expression that we just saw here, the parentheses govern that 3 plus 4 is computed first to get 7. And after that, you get 2 times 7, which is 14. If you leave out these parentheses, you get something else, because the multiplication has a higher priority. So here you would have 2 times 3, which is 6, and then to 6 you add 4, and you get 10 in the end. And this does not have to do with ordering from left to right. If you write the plus here and write the multiplication sign here, the multiplication is done first. 3 times 4 is 12. And to the 12 to the right, you add 2, and you get 14. So multiplication and dividing has higher priority than plus and minus, and is done first if you don't indicate something else with parentheses. So sometimes you have to write out parentheses, and in my view, you should write out parentheses when you actually need them, and never if you don't need them. If you can use the natural priority rules, then you should do that, because unnecessary parentheses just clutter the notation for you. Yet higher priority than multiplication and dividing has the power. So that is the one with highest priority. So if you write something like this, the power computation will be done first. 3 to the power 4, which we saw before was 81. And then this 81, the result of 3 to the power 4. 3 times 3 is 9. 9 times 9 is 81. Then this 81 is multiplied by 2, and you get 262 as a result. 162, as you see here. We have seen the predefined constant pi. Actually, I don't know many two other predefined constants. You would expect, for example, that the famous mathematical number e could be a predefined number. Well, it isn't in MATLAB, so if you write e like this, you get nothing. Undefined function or variable e. E does not exist. On the other hand, there exists an elementary function, which is the exponential function. So the exponential function is one among many predefined elementary functions. But you cannot write e to the power 3, for example. That does not make sense because the e does not exist. E, which is normally considered to be 2.7 or something like that. So this does not work. Instead, you write exp for the exponential of 3. So this means the famous number e, 2.7 to the power 3. And this is the result, a little bit more than 20. If you like, you can define e to be a number. If you do it like e equal the exponential of 1. E to the power 1 is 1e. So now e exists and is 2.7. So now you can write e to the power 3 if you like, and you get the same number, 20. Besides the exponential, there is a log function. The natural log function in MATLAB is not called ln, which is common in many math books, at least in that math books that I've seen, but rather it's called log. So the log of 10 means how many e's, how many e factors do you need to get 10 as a result? And the answer is a little bit more than 2, I guess. So you get 2.3 e factors to get 10. In addition to the exponential and log function, you have the sine function, of course. And the sine function works with radians. So if you write sine 90, this is not interpreted as degrees. Sine 90 degrees would be 1, but this is sine for 90 radians. So that is something else. If you want to use the trigonometric functions and use degrees as an input, you would have to write sine d. So you add a d to the name of the trigonometric function, then you can work with degrees as a unit of input. So this is sine for 90 degrees, which is 1. And besides sine, of course, you have cosine and tan and all the other trigonometric functions. In MATLAB, you can also define functions of your own. That could be functions that you need temporarily because you would like to use them a number of times. You have a rather long expression, for example, and you would like to use this many times. So there is a fancy way you can do this, and it is as follows. So you indicate that you would like to define a function with this symbol, the @ symbol that is used in email addresses. And then within curved parentheses, you list the number of input variables. So normally a function is just a function of x. And then you tell what you should do with the x to get the output. For example, you might want to do double the x and add 3. Sorry, double the x, that is 2 times x, plus 3. So this is the function that takes x as an input, doubles x, and adds 3. Now, this function doesn't have a name yet. So if we would like to name it, we put the name of the function to the left here by writing f equal. This will give the function the name f. So f is now a function for temporarily use this work session that doubles x and adds 3. Now it's defined, and now I can use this as a regular function. So I can write f4, for example. Then 4 is the input, which will be doubled to make 8. And then to the 8, we will add 3, and the answer would be 11. Functions like this can also have several inputs if you like. So you can create another function with the name g, and you start the symbol for defining a function, which is this one. And here you put your inputs. They could be x and y. And then you tell what you should do with the x and the y to get the result. Maybe you will take x times y. Just take the product of the two. So now you have created a function that multiplies x and y. And then you can use this as follows, g, and then give 2 values, a 2 and a 3. And this function will simply compute the product of these two numbers, and the result will be 6, like this. So you can create functions of your own. But these functions will not last. When you close down MATLAB, these will be gone with the rest of your variables. What is very important to MATLAB, and what you can even hear from the name of the product, is the concept of matrices. Actually, MATLAB means matrix laboratory. Matrix laboratory. So to create a matrix in MATLAB, you start with a bracket. So you define a MATLAB matrix within brackets. And you simply list the numbers you would like to have in your matrix, which thankfully could be 2, followed by a 3, and followed by a 4. So this is numbers on one row in the matrix. If you would like to go down and make another row in your matrix, you introduce a semicolon, and then you put the numbers there. And of course, there has to be the same number of numbers in each row in a matrix. So here we have defined a matrix now, having 2 rows and 3 columns. 2 rows and 3 columns. So this is not what is called a square matrix, but you could call it a rectangular matrix, maybe. You can get information about the size of a matrix by using the built-in function size, and you would get to know that this matrix has 2 rows and 3 columns. 2 rows and 3 columns. Now, this matrix doesn't have a name. It is put in the answer box, as you can see. We can give it a name, M, by copying what is in the answer box. So by writing this, I look up what is in the answer box, and I give that the name M. So now this matrix has a more private name, if you like. And as I said, we can use the function size with M as an input to get information about the size of a matrix. So we see here that this has 2 rows and 3 columns. The outputs of these functions are given in this order. First, you get the number of rows of the matrix and then the number of columns. A matrix, of course, as a special case, can have just 1 row or 1 column. These are also matrices. And in fact, a matrix can also consist of only 1 number. Just a single number is also considered a matrix in MATLAB with 1 row and 1 column. So now we come to the algebra of matrices. You know that if you have a square matrix like this one, you can also discuss what is called the determinant of the matrix and the inverse of a matrix. And there is a built-in function in MATLAB called det that gives you the determinant of a matrix. And the determinant, of course, tells you, among other things, if the matrix is invertible or not. And this one is, because the determinant is non-zero. So then it makes sense to try to compute the inverse of the matrix. And there is a particular function for that called inv, in for inverse. So the inverse of the matrix A above is this one. So this means that this is a matrix for which the product with A would be an identity matrix. So I can now take this matrix, which is in the answer box, and I can multiply it with A, and the result should be an identity matrix. That is a matrix with 1s on the diagonal, and the rest would be zeros. And this is what you actually see here. You see some decimals also, but basically there is a 1 up to the left and down to the right, and the other numbers are 0. And now we come to matrix algebra. Suppose that we have another matrix besides the M matrix. Well, we now have A and we have M here. It makes sense actually to multiply these matrices. So if you write A multiply with M, you would take rows in the A matrix and multiply these with all the columns in the M matrix. And the product of the rows in A with 2 numbers and the columns in M with also 2 numbers with the scalar product. So you multiply the 2 components involved and you add the result. And the result of this product will be the 2 times 3 matrix. And here is the result. As I said, we can have a special case of matrices consisting of just this. And suppose that you would like to multiply these numbers with some other numbers like this with the product. I said before that there is a colleague of the star symbol for multiplication. Sometimes you would like to do component-wise multiplication. That means multiply each component in one list of numbers with the corresponding number in the other list of numbers. This is very, very common. And then using just the star does not make sense because just a star means a matrix product. And for a matrix product to make sense, the length of the rows in the left matrix must be the same as the height in the second matrix. And that is not the case here. So if we try to multiply like this, it doesn't work in MATLAB. You get an error message like this. MATLAB tells you that the inner matrix dimensions must agree if you would like to do a matrix multiplication. And this is what the star symbol is used for. So in this case, if what we would like to do is to multiply the 1 with the 4 and the central number, the 2 by 5 and 3 by 6. Then instead we use the dot star symbol. Dot star for component-wise multiplication of numbers. So now we get 1 times 4, 2 times 5, and 3 times 6. And these three products will not be mixed, but rather we will get a new list of 3 products, as you see here. Correspondingly, you use the dot in front of the divide sign, the slash, which we have here. And also when you would like to do powers. So if you have the numbers 1, 2, 3, for example, and if you would like to have the squares of all these numbers, this does not make sense again, because when you write just the power, that means that you square this as if it were a matrix. And again, that does not make sense. So here you will get an error message. As you see, doesn't work. So maybe what you meant to do was to square each individual number in the list here. And then you use dot hat. Dot hat for squaring each individual component in your matrix. And you get the square of the 1, the square of the 2, and the square of the 3 as a result here. Often you would like to deal with lists of numbers that are longer than this, but also in many cases structured. So for structured list of numbers, there are a special command called linspace. So let me introduce you to linspace, which is a very useful function. So to use linspace, you introduce 2 or 3 inputs. So first you introduce the first number in the list. That could be, for example, the number 2. And then you introduce the last number, which could be, let's say, 5. And lastly, you tell how many numbers altogether you want in this list. So suppose that you want 4 numbers, for example. Then you will get 4 numbers ranging from 2 to 5, and they will be equally spaced. That means the distance between the numbers will be the same. So you get 2, 3, 4, and 5. 4 numbers starting with 2, ending with 5. If instead you would say that, okay, I want only 3 numbers, then they will again be equally spaced. The first will be 2, the last will be 5, but there will only be 3 numbers now. So you get 2, 3.5, and 5. So this is indeed a very, very useful command. For example, if you would like to do plotting work and so on. It actually also works backwards, if you like. If you put a -5 here, means that you start from the number 2 on the x-axis and you step backwards 3 steps until you reach -5. And you get this sequence of numbers, 2, and you step back 3.5 step to -1.5, and then another 3.5 step back to -5. So this was linspace. This is now a one-dimensional matrix, a matrix consisting of only one row. There is an operation concerning matrices which is called transpose, where you make rows to be columns and vice versa. So if you would like to put these numbers on top of each other instead, they are in the answer box. You just put this single quote after. That will turn this matrix over to make it what is called a column matrix, in this case consisting of only one column. You can do this transpose operation to any type of matrices. I can just create a random matrix with 2 rows and 4 columns. You see it here. Maybe I can make this a little bit a little bit bigger so that you actually see that this is a matrix consisting of 2 rows and 4 columns. If we now transpose this, we will have 2 columns instead and 4 rows. And the matrix would look like this. The ANS that you saw here is a name of a variable in MATLAB. ANS have had different contents from time to time in this session. To the right here, we also see some other variables. We see A and M and E and F and G. All of these actually, the first 4 contain matrices and the last 2 contain functions. So you see some different symbols here. So F and G are functions of X and Y. But A, M, and what is currently in ANS and the E are matrices. Variables are simply memory positions that can have different content from time to time. They are named positions in memory which can have different content from time to time. There is a convention for what kind of names you can use. For example, you can call a variable A4 like this. So now we have created another variable with the name A4. So this is a perfect name for a variable, but you cannot call a variable 4a, for example. So names must start with a letter, but it can contain numbers and some other symbols on the keyboard. Not all of them, but some of them. As long as there is not confusion with other variables. For example, we could test the name this one. Does this work? Probably not, because we got this red text. A underscore works. A percent doesn't work because percent has another meaning. Percent actually in MATLAB is the start of a comment. That means that MATLAB actually ignores what comes after a percent sign. You can see that with the green color here as well. So what will happen now is that we will just get to see the content of A, if there is a content in A. And we know that there is a matrix in A. So we will get to see the matrix A that we see up here with its content 1, 2, 3, and 4. And the rest here, the percent and what comes after, is just considered a comment, which MATLAB ignores. So we just get to see the A. So now you know the concept of variables, and to use variables is very, very practical. And the ANS variable then is a special one. This is the default one for placing output, unless you don't place the output somewhere else. Again, you can write things like this: A equal 4, that is perfectly okay. But you cannot write 4 equal A. Normally this would be the same. But this is not the same to MATLAB, because the equality doesn't necessarily mean that 2 things are equal. The equality sign means that 2 things get to be equal. So what happens when you write something like this? MATLABs always look to the right side of the equality sign, computes what is there to the right of the equality sign. That is the content of the box A. The memory position A has a certain content, in this case a 4. And then this 4 is put in this variable, but a variable may not have the name 4. So you cannot write things in this order. To the left of the equality sign, you should have a legal name of a variable. And to the right of the equality sign, you can have everything which is computable. Everything which is computable. So that means that the equality sign is not completely symmetric. In many programming languages, therefore, one use notations like this, for example. So that means in MATLAB, the equality sign is actually an assignment. That is, you give A the value 4. You define A to be equal to 4. So there is information goes from the right side of the equality sign into the left side. So I think this is part of what I would like to say, but there is a few more things. We can go back to the matrix M, as we see here. There is a possibility to address individual parts of M that we need to learn as well. So here we see the complete matrix M. Suppose that we would like to change a particular number in M here, or look at a particular number. Then we specify an address into M in this way. So we say that we want the number that is in the second row and in the first column. We would write this as we see here. So in the second column, second row and first column, there is the number 5. And we get to see that here. And if we would like to change a number, okay, this is the address or the place in a certain memory which we would like to place, and maybe we would like to change this to 8. Then we would do it like this. MATLAB would look to the right of the equality sign, find the number 8 there, and put this to the address to the left, row 2, column 1 in the matrix M, which will be changed then from 5 to 8, as you see here. So at this point, I think this is all that you can take for the moment. So we stop here and hope to see you soon again with more stories about MATLAB.